All right, so question number 13 asks, why can plants make glucose out of acetyl-CoA, but we can't? All right, the simple answer for this is because in plants they have something called the glyoxylate cycle that we lack. All right, now what's special about the glyoxylate cycle? Now, in order to make glucose, first of all, so if we're going to go around and make glucose, we have to be able to turn molecules into oxaloacetate using the citric acid cycle, because oxaloacetate then goes up through gluconeogenesis, up to PEP and so on and so forth, right? So oxaloacetate is kind of our key molecule we have to be able to make. Now, in the citric acid cycle, right, we can add in acetyl-CoA, but the carbons from acetyl-CoA end up leaving as CO2 along the way before they get to oxaloacetate. So as a result, we can't actually turn acetyl-CoA into oxaloacetate because those carbons are just simply being lost here. All right. So and this gets into the whole how acetyl-CoA being added to the cycle is not anaplerotic because it's not contributing to the material that's actually physically in the cycle. It's acetyl-CoA basically hops onto the cycle and then hops off again. All right. Now, in the case of the glyoxylate cycle, right, the glyoxylate cycle uses a couple of extra enzymes that bypass the decarboxylation steps of the citric acid cycle. So as a result, the acetyl-CoAs, and there's actually another acetyl-CoA that enters in. These acetyl-CoAs that enter in now, they're not being lost off of here. So they can actually get physically turned into oxaloacetate. And then, since there's now more oxaloacetate being generated, oxaloacetate can then leave this cycle in a cataplerotic reaction. So anytime we're losing a molecule from the cycle, that's a cataplerotic reaction, and generate glucose. And that is it for number 13.